Hi guys, I hope you are fine. Me too, I'm fine. So today guys, we are going to look or to continue to look at vectors. And here is a question. I am going to read it. Given the vectors A, that is what we have, and B, determine the angle between A and B. So the first thing guys, we use this equation. This equation is what you are using, that that is dot B is supposed to give us that. This is magnitude of A, magnitude of B. So finally, when we now we manipulate that equation, we get that. So finally, our theta is going to be cos inverse. This is called cos inverse. This is 1. That is minus 1. A dot B, all over magnitude of A multiplied by magnitude of B. So A dot B, you just multiply, for example, 3I multiplied by 2I. That one you get 6. Then you come here, 6J multiplied by minus 1. You get minus 6. 2K multiplied by 3K. What you are multiplying is the coefficient. Not the I and J, but the coefficient. 2 times 3, you get 6. So when we add that, guys, is what now we are getting as our dot product. That is supposed to be 6. That is our dot product. Maybe to repeat, because it was a bit hidden, you multiply the coefficient of I, both of them. You multiply the coefficient of J. This is -1, this is 6. Coefficient of 2 of K this side and of 3 and of K this side, you get 6. When you add them up, that is what we call dot product. For the magnitude of A, we go to our vector, and our vector, as we said, is supposed to be here. That is, the A is this vector. So the magnitude for that will be 3 squared plus 6 squared plus 2 squared, then all of it square root. And this is what is demonstrated here. So when you do the square root of that, you get 7. That is now the magnitude. And for B likewise, so you go to the vector B, then you square the coefficient of I, which is 2, coefficient of J, which is 1, and coefficient of K, which is 3. Then you find the square root, that is the square root of 14. Finally, now we can replace in this equation. So we have the dot product, which is 6 here, and we also have the product of magnitude of A and B. And guys, when we do that, we get the inverse of that, we shall get that. So that is the angle between the two vectors. That is A and B. Then we come to the area of parallelogram. For the area of the parallelogram, this is similar to the cross product. Similar to the cross product, of which we get it by use of this arrangement. It's like we are looking for the determinant of this matrix. This is our A here, and this is our B vector here, represented in terms of coefficient, while the I, J, and K are there. So when you look for the determinant of that, of course not forgetting our pattern of plus, minus, plus, as in matrix, for the first row, when you are using the first row to determine the determinant, and that's why we have negative here. So when we do that, we are going to get the matrix as this, not the matrix, the vector or the cross product is going to be like this. But now we can get the magnitude for that. Magnitude for that is, we disregard the negatives and then we square that. Then we get the square root. When we get the square root, this is now what is the area of the parallelogram. as you can see here, you have the cross product, then you get the magnitude. That now gives us the area of the parallelogram formed by these two vectors. And so guys, we continue from there. Question 5, this one reads, determine the value of P such that three vectors are coplanar. When we are talking of coplanar, guys, is when these three vectors, when you find they are actually in the same plane. At the same time, guys, when you look for their dot product, that is when we come and say that is dot product of A that is dot multiplied by B cross product of B and C, they will always give us 0. So that's what we are going to rely on, whereby the product of that gives us 0. So for that, we come first of all write B and C. For B and C, it is here. Then this is our A. When we multiply those, guys, we are supposed to get 0. And this 0 is now what we use to find the unknown value. We equate all of whatever we have gotten here, we equate to 0. And whatever we've gotten here, guys, is actually here. This is what we get. Because when we are multiplying here, guys, we only multiply with the first law, coefficient of the first law. The coefficients of the first law are 1, this is 1, and this is also 1. This is what we are calling dot product. And here we have the cross product. So when we want to get the dot product, we multiply this vector A with this only in the first row. And when we do that, this is what we get. We don't multiply the other rows because now we are dealing with dot product. From there, guys, we come and find the magnitude of that, which we are now, not the magnitude, we come find the determinant for that. When we get that, that's what we are now going to equate to 0. When now we equate to 0, that's then when we are going now to find P, and the P now comes to 4. So this is our solution, guys. Yes, from there, guys, we come to this other question, which is written, given that is phi equals to that, determine grad phi at a point that. So this is our solution, guys. And this one we do it by using what we call partial differentiation. So we do partial differentiation for this. First, for partial differentiation with respect to x, that is for I. And for j, we do the partial differentiation with respect to y, and this one with respect to z. So guys, we take the whole of this. We come here, partial derivative at x equals to 1, y equals to 3, and z equals to 2. We do it, all of it, guys. We do the partial derivative with respect to x. So whatever we'll get here, we shall multiply now with I, as we have seen. Then we do again with respect to y. Whatever we shall get after replacing 1, 3, and 2, we shall multiply that with j. The same case, we do that with respect to z. So when we do that, guys, this is what we are going to get. With respect to x, we have gotten this. Actually, we had done it already. It's only that we had not replaced. We already done this with respect to x, because the equation we are actually finding the derivative is actually here. It's actually here. This is what we are finding, the partial derivative. First of all, with respect to x, this is what we get. Then secondly, with respect to y, we get that. and that with respect to z we get that. So after that is when now we come and replace our figures. So when we replace our figures, guys, that is for the this is for the first, this is for x, y, and z. We replace that, we've gotten 84. This is the 84 we are multiplying with I, because this is our derivative with respect to, partial derivative with respect to x. For partial derivative with respect to y, having been replaced, we get that 2. This now is going to be our j. For partial derivative with respect to z, we replace the values of x, y, and z, we get 72. So finally, guys, this is our solution is here now, guys. This is now what we are calling glad phi. That one. It's written like that. So guys, that is how we do that question. So finally, guys, we have the last question here. And it states, given that phi is equals to that, and f is equals to that. You can see this is a scalar quantity, or this is actually a vector quantity. Determine at the point that you look for that one, that is grad, that is phi. And then we come to the, you look for unit normal, you look for the grad f, and this is the grad, this is multiplied by cross product of that and that. So for the first one, guys, we just do it as we have done the former one, and this is how it is done. We come and find the derivative of partial derivative with respect to x for the first one. The second one is with respect to y, the third one is with respect to z. After replacing all this, we now come and multiply by I for the first, for the partial derivative with respect to x. For the partial derivative with respect to y, we multiply by 4. And for the partial derivative with respect to z, we multiply by 3. So this is what we now get for that delta phi. For the unit normal, whatever we have gotten now, we come and now divide by the magnitude of that. And the magnitude of that is given by 4 squared. We disregard the negatives. So it's 4 squared plus 4 squared plus 9, then square root. So this is the normal to that. That is unit normal to that. So that is our solution, guys. Then we come to this C. For C, we come and now say this delta is actually the derivative of the firsts, whereby we were saying with respect to x, that is of the first function, of which for us we have this function here. The derivative plus j derivative with respect to y, derivative that is k with respect to z. So we multiply now here, guys. You multiply this, the first one you multiply with this. The second one we multiply with that. That is what we are calling the dot product. That is the derivative now. So when we multiply, finally we are going to get something like that. When we actually multiply this and that, we get that. The second, we multiply this and that, we get that. The third, we get that. Then we can now do the partial derivative with respect to x. Then that's what we get. With respect to y, we get that. And with respect to z, we get that. And now we can replace our figures. That is 1, -1, and 2. And after we do that, we will get that. When we get, this is 1, we put, where there is x, we put 1. Where there is y, we put -1. Where there is z, we put 2. Finally, we will get that. So that is our answer for C. And finally, we come here now. This is now what we are calling curl. This is what we have. We have, this is we are saying this is the derivative. Now we do cross product with f. For us, for this one, we will do like we do in matrices. You remember when it was dot product, we are just using the first row. But now for the cross, now we shall do it as we would do for matrices. So we shall come and write this I, J, and K there. Then we write this and that. Then we do the way we do for matrices. That is finding the determinant. And this is how we do it. We close this row and then we can now the major diagonal minus the minor diagonal as shown here. And this is what we have done, guys. I have done, guys. Until finally we come to our answer as it is written here. So this one is quite different because this is the cross product. So we put our figures here and then we can be able now to do like we are looking for the determinant. Of course, not forgetting the pattern plus, minus, plus. So guys, thank you for listening to me. And this is how we do that.